everybody! I am going to spend a little bit of time in this video showing you how to use one of these things. This is a spectroscope, okay? And so what this does is this is a device that is used to separate light emitting from a source into its atomic spectra. You can use a spectroscope, that's where it gets its name from. Atomic spectrum is determined by a spectroscope. You can get information about what element is in a light source by using a spectroscope. So let's take a minute and I'll set up a little experiment and we can look and see what we get. Okay, so what I have here is a light bulb, and inside the light bulb is only neon gas. Okay, so what we can do is we can turn this on, and you can imagine a light bulb with just neon gas is going to come up with something that you're familiar with. So here we go, look. So notice that this shines very bright red, okay? And we could do this with all sorts of other elements. Here's chlorine. Notice that it gives a purpley blue glow. Krypton is kind of this whitish glow. Argon gives this beautiful purple glow. I'm a huge purple fan, so this purple is my sort of color. One of the things the spectroscope will do is it will take this light and it will separate it out into a atomic spectra. So what I'm going to do in this video is show you atomic spectra of different elements, and we'll start with neon. And I'm hoping to show you that real life atomic spectra sometimes can be a little more challenging than maybe canned atomic spectra that you find on the internet. And so the hope is that you can match up the actual atomic spectra from using the spectroscope with one that is canned. So in order to do this, we need to go over how to use a spectroscope and what you're going to expect. So the thing that you're going to want to do is make sure that the hypotenuse of this triangle is on the right hand side. And you'll notice that there's on the top there's an eyepiece. That's what you're going to look through. And on the bottom of this, there's a slit over here that you're going to line up with the light source, and then you're going to read this, which is off to the right. So I would look at it like this and see stuff. You would kind of look at it like this, and you can see the slit right through there, and you're going to line that slit up with the light source. And then when you do, you look over here, you see the scale and the numbers that you would get that is going to show where the spectra of the element is going. So let's take a look at neon. I've lined up the neon light source with the slit on the spectroscope, and you can see the reddish color through the slit. But we want to ignore this thing on the left. That thing on the left is a reflection, and it's going to screw you up if you look at that. So you only want to focus on the thing on the right. I'm actually, in a second, I'm going to get rid of all this, and I'm actually going to cover up the thing on the left with choices so that we can try to match it up. So there we go. So when we try to figure out if this spectrum on the right matches up with A or B, we look at the colors. Notice that the thing on the right, from the spectroscope, has red, oranges, and greens. Well, if we compare, the spectra A has red, oranges, and greens, but B doesn't have any reds and it has purples. So if we were going to guess which spectra this is, we would say that this is spectra A. And then we can go to the internet now that we have the clear picture, the clear idea, spectra A, and then we can say, well, what is spectra A? We know that it's neon, though. So we can go from there to identify what elements are in unknowns. So let's take a look at some other elements and see if we can figure out which spectra they are. And so now this over here on the right-hand side is chlorine. So when we look at chlorine and we're trying to determine which one of these it is, I think it's important to look at how many different colors there are in the actual spectrum. The one on the right, the actual spectrum, has a whole slew of colors. It's got everything down to blues, and there's a couple of brights at the cyans and things like that, and reds. And if we look, that is more symbolic of B, with all the different lines in it. Element A has just a few lines in it. So I think this is going to be spectrum B. So what we're going to do is you're going to take an opportunity to try to figure out which one you think it is in the next few examples. In this, you have krypton over there on the right, and my hope is that this is a pretty obvious answer. So make sure you write your answer down. And then you may want to pause the video if you need a little bit extra time to look at it. And you can pause the video anytime you want to do these. That way you get some extra time to look at it. But we will move on to the next one and go from there. So as everything disappears, you should have 7 different answers for the 7 different elements that we determined spectra for. And so what I hope is that this highlights that the canned spectra that you get off the internet will be much different than you see in a spectroscope.